All right, as far as this goes, we are looking at a computer chip that's made up of a lot of different layers of silicon. And I'm going to focus in on that small area right here. And I'm just going to enlarge that. All right, so you can see I'm just enlarging that. And this is now fairly thick. All right, so what we need to understand is that it's a bunch of layers. So I've got an upper layer, which is 0.03 in thickness. I've got, maybe I'll extend this the whole way. And then I've got a bottom layer, which is 0.03 in thickness. The entire width of this is 0.32, which means I need to figure out how much is left in the middle. So if I do the 0.32 and then I subtract 0.03 and subtract another 0.03, I get 0.26. So that means there's 0.26 centimeters of thickness, and I will kind of at this point figure out if all the layers here, and I'm not going to pretend that these are different layers that are 0.02 thick. Basically, I can just divide 0.26 divided by 0.02 to figure out how many layers will be required to fill that in. And when we do that, we will get 13 as our answer. All right. So the answer is indeed A. And a lot of people answered C in first hour, and I'm getting quite a few who are saying C for for this question as well. And that's when you forget that the top layer and the bottom layer are a little thicker, and they take up part of that total thickness. Okay, so let me go and clear that. So yeah, we can see mixed practice. We're just going to be looking at what we do whenever we've got a, when you're looking at a diagram and you could use either one of those theorems, and we need to determine which one is appropriate for this particular problem. So you can see there's just a PDF on Canvas that you're going to be working on tonight. And I will go ahead and pull that up, which it looks like this. All right. So what we've got, I'm just going to get a couple things ready. All right, there we are. So what we've got is a mix, and notice that there are certain problems that are circled and certain ones that are not. Just ignore anything that's not circled. And there are 12 problems as part of this tonight. And what you will need to do is kind of look and determine what's the appropriate theorem for you to use. And what you're going to notice also at the top here is that there are 4 options. There's mid-segment, side splitter, similar triangles, and angle bisector. Now, I did briefly talk about angle bisector just to mention it, but we didn't really learn it, so don't worry about that one. And similar triangles is something that's a little different, and we're not going to worry about that one either. So basically, if we ignore all that, we're either going to be looking for the mid-segment theorem or the side splitter theorem. So if I'll just focus on number 1, and this will kind of illustrate what you're looking for to determine what's the appropriate theorem for this problem. So the key thing with mid-segment theorem, the giveaway that it's going to be mid-segment, is that you're going to be looking for congruence marks, because what these congruence marks tell you is that these 2 points are midpoints, and therefore ED is a mid-segment. So if you see congruence marks, it's going to be mid-segment theorem. And you're always going to see a complete triangle with this. When it's side splitter, you won't always see a complete triangle. But if it's mid-segment, it's going to be a triangle, and you're going to see the congruence marks. All right, so that's the key thing. And if that's still confusing, we can go through some more of these, and you can kind of determine, is it mid-segment or is it side splitter? So knowing now that this is mid-segment, another thing that you'll notice on this one that's different is that the lengths that they give you are along these parallel lines. There's nothing here. Now, theoretically, I could give you something here, and you've done some practice problems with it, but in this case, the information they give you is right here. So that's going to be another sign that it's mid-segment. And the reason that's important to identify is because we need to set this equation up a little differently. So the equation that we use here is that 2 times your mid-segment is equal to the parallel side. All right, so that means my mid-segment is, of course, this one right here. It's where the midpoints connect together. So 2 times that length, x plus 2, is going to equal the parallel side, which is that guy right there, 3x minus 5. So now I can just go through. This is the hard part of the problem. Once you've got the equation set up, it's just straightforward algebra. And that means I'm going to use distributive property. 2x plus 4 equals 3x minus 5. I can add 5 to both sides. So those cancel out. I get 2x plus 9 equals 3x. Now I can subtract 2x from both sides. And x equals, when I cancel that out, x is going to equal 9. And here I'm using mid-segment. Now that box is there in order to remind you that it's, you can put in the code mid-segment or side splitter, and that is the intention behind it. I know when you submit your problems, you're just going to submit it as a Word document. So what you could say is like, okay, it's MS because of mid-segment, and x equals 9. I know I won't see your work. It's up to you to be able to work through it. But that's okay. If you can just show me that in your Word document. So for number 1, and this is an actual one of your homework problems. So I am giving you one of the answers to the homework as we work through this. But it's not just like, oh, great, there's the answer, let's move forward. You need to understand the process. So are there any questions on this before we move forward? Okay. I do want to remind you that this equation and this setup is in the reference sheet that you have available for you you have available, so you can have that pulled up as and switch back and forth between the reference sheet and the homework. So if you want to just constantly be seeing what is one way of setting up the mid-segment type problem, you have that as a reference. So I'm going to clear this and I'm going to go down to problem number 5. This is another one of your homework problems. So I'm doing 2 of these. Now, one of the things we talked about a second ago is how do we know if this is side split or mid-segment? I mentioned when it's mid-segment, you're going to see the entire triangle. So this, we don't see the entire triangle where that all comes together. It doesn't show us. So this is going to be a clue. Okay, it's probably side splitter. But also notice there's no congruency marks given anywhere, right? So, I mean, those don't exist. So if we don't see any congruency marks and we don't see a triangle, then this is certainly going to be side splitter. And the thing that we're looking for are all these parallel lines that are cutting through 2 other lines right here. And when we get those lines cut, they are cut proportionally. So now we can, if we determine it's side splitter at the beginning, then we can set up a proportion. And I can set this up a lot of different ways. So I've got this 2 corresponds to the x, this 8 corresponds to the 12. And I can set it up lots of different ways. Let me do left over right. So 2 over x equals 8 over 12. So left over right equals left over right. It's the pattern of correspondence. That's how we set up these types of problems. So if I have the same pattern going, left over right equals left over right, and I'm talking about the corresponding parts, then I can go ahead and feel confident that this is the correct proportion. And now I can set it up like this. So 8x equals 2 times 12. So now I can multiply this out. 8x equals 24. Divide by 8. And x equals 3. And there's my answer. So, and I would, on the online submittal, I would say I used side splitter theorem and I got x equals 3. All right, keep in mind on your test, you're going to have to show your work. And this is what I'd be looking for on the test. But when it's just practice, all I'm really looking for is the final answer. I'm sorry, I'm losing my train of thought a little bit. So that's the main idea with this for today. So just for those of you who are coming in a little bit late, not realizing we had a different schedule today, today's practice is just a mix of side splitter and mid-segment theorem. All right, so with that, if there are any questions, if you want to see more examples of this, if you have questions about doing test retakes, some of you still need to finish tests. If you have questions about any of that, feel free to stick around. Otherwise, you can have yourself a wonderful day and just get to work on all this practice.